I'm Mark Olson. I'm a principal engineer, and I've been thinking about storage and virtualization at AWS for the last 10 years. Today, we're going to talk a bit about EBS. We'll dive into some of the technology that you heard about earlier behind Block Express, our new SAN in the cloud offering. But before we get started, let's take a look at where EBS fits into the AWS storage portfolio. As you'll learn throughout the day, AWS has three main types of storage. We have object, block, and file. And we also offer a range of options for backup storage. These solutions are designed to provide cloud scale, low-cost secure storage, but with different interfaces to meet the needs of your applications. In this session, we're going to talk about block storage. Now, block storage is found in all kinds of computers and mobile devices. Practically anything that has local storage has something like a hard drive or an SSD where data can be written, usually via a file system, to help keep everything organized. Block storage differs from object and file in that it doesn't rely on metadata for storage and retrieval, so the read and write times are really fast. For EC2 instances, you have the choice of either local instance storage or EBS. You can think of local instance storage as a raw disk, protected by the security of our Nitro controllers, directly attached to your instance. So if instance storage is a raw disk, what is EBS? EBS is a large distributed system. Actually, it's a few distributed systems that provide high performance, highly available, and highly durable block storage over the network to any EC2 instance. And it's designed for most workloads at any scale. The most important thing to remember, though, is that an EBS block device, or what we refer to as an EBS volume, is not just a disk. An EBS volume is actually a collection of shards that store your data throughout our infrastructure. As you'll see in a bit, the way that we've built EBS allows us to continually deliver new features and functionality. Now, when you have an EBS volume, what can you do with it? EBS volumes can be attached to an EC2 instance in the same availability zone, and it appears in your instance just like any other disk. You can create a file system, write data from your EC2 instance onto the EBS volume. Now, because the EBS volume is connected over our storage fabric, it separates the life cycle of the compute and the storage, and so your data is persistent, which means that it's there even if you disconnect your EBS volume from the instance. EBS volumes have performance characteristics similar to what you would expect from a local SSD or hard drive. And within those families, we offer a variety of volume types with different performance, price, and durability characteristics designed to match the needs of any application you can run in AWS. All management of EBS volumes, including lifecycle features such as creating and deleting or even changing the type, size, or performance characteristics online, which is really cool, is available through the tools you're most familiar and comfortable with, whether it's the APIs, the AWS SDK, or the AWS console. And with all volumes, you can take point-in-time snapshots of these volumes for retention and recovery. Now, we launched EBS 13 years ago in 2008, and today it's used by millions of developers to store exabytes of data across millions of EBS volumes, driving trillions of I/O operations every day. In that time, we've come to understand what customers care most about using block storage in the cloud. Customers value high performance for their most resource-intensive applications. This means high IOPS and throughput, but it also means that I/O needs to be fast and consistent. So our SSD volumes, like GP2, GP3, IO1, and IO2, are built to deliver an average single-digit millisecond latency. While our new Block Express architecture that we'll talk about in a moment, and the IO2 Block Express volumes that run on it, are designed to deliver sub-millisecond latency. As a distributed system, we think about reliability in two ways. We know that customers want to get their data when they want it, and they want that data to be safe. Now, the first way that we think about this is through availability. EBS volumes offer 5 nines of availability, and we define availability as the ability for your EC2 instance to get to the storage servers that actually store your data. The other thing that we think about, since we're a storage service, is durability. And with EBS volumes, you can have durability as high as 5 nines, or a failure rate as low as 0.001% on our new IO2 volumes. Customers also want their block storage to easily grow as their application grows. Whether it's second over second, year over year, individual EBS volumes scale from single gigabytes up to 64 terabytes, and you can scale them online. You can even have petabytes of total storage in your account, supporting everything from massive enterprise databases to pods of hundreds of short-lived little stateful containers. Tools like Elastic Volumes allow you to switch between volume types, increase storage, and right-size performance, making EBS easy to manage and scale with your business. Other tools, like EBS Data Lifecycle Manager, make it easy to set up backup schedules and retention policies for your volumes. Of course, your data must stay secure, and EBS supports AES 256 encryption that's as simple as clicking a box. Or, if you want to make it more advanced, it's advanced using self-managed KMS keys. Now, thanks to our Nitro infrastructure, EBS encryption has no impact to performance, and there's no reason you shouldn't enable it to secure your data. In fact, with a simple click, you can enable it by default for all new volumes in your account. And like all AWS services, customers push us to do all these great things at the absolute best value for their money, with cost-effective pricing that scales only as your workload and usage scales. These 6 areas are what we hear most about from our customers. So these are the areas where we drive the most innovation into EBS. And so you can see the focus and capabilities of features and capabilities that we've delivered since we launched. Back when we launched, we had one volume type and the ability to snapshot those volumes to S3 backup, something we consider table stakes today. That first volume type, now called standard, was backed by hard disk drives and offered up to 1 terabyte of storage with no performance guarantees. Since then, we've expanded the volume offerings quite a bit. The provisioned IOPS IO1 volume was our first SSD volume and our first volume with a focus on performance consistency. Then came a lower cost SSD option, GP2, followed by the lower cost hard drive volumes, SC1 for streaming workloads, and ST1 for higher throughput streaming workloads. And of course, our recent volume launch, IO2, offering higher IOPS per gigabyte and lower AFR than any other EBS volume. Around these volumes, we've continued to innovate across all of the other things our customers care about. Now, we can't cram all 13 years of features and innovation into this slide here, but things like Elastic Volumes, Data Lifecycle Manager, encrypted volumes, and more have provided a stream of innovation that continues to give customers more value for their block storage every day. So let's take a look at IO2, and we've even innovated on IO2 since we launched it. Last month, we announced the general availability of our highest performance volume ever, IO2 Block Express. Now, we've been working for several years now on a series of foundational changes inside of EBS. They include building a new storage fabric based on the SRD networking protocol, optimizing our instance data path with Nitro, and completely rethinking our storage hardware designs. The result of that hard work is an architecture we call Block Express. Now, IO2 Block Express volumes offer 4 times the performance of IO1, up to 256,000 IOPS, 4,000 megabytes per second throughput, and you can provision up to 4 times more storage, creating volumes as large as 64 terabytes. And perhaps most important for your demanding applications, IO2 Block Express offers these high performance numbers at an average sub-millisecond latency, the first EBS volume to do so. So we can take a look at that performance curve I showed you and extend it up to the right just a little bit. But for those of you familiar with the EC2 instance types, it might occur to you that the performance of IO2 Block Express is now higher in IOPS and throughput than most EC2 instances can drive. Last year, as part of our preview announcement of Block Express, we also announced the R5B instance family. The new R5B instance keeps the same memory and compute ratios as the R5 instance family, but offers 4 times the EBS optimized performance, now up to 7,500 megabytes per second, and more than 3 times the IOPS at 260,000, more than any other EC2 instance. Customers love the R5 instance family for their database and in-memory caching solutions. And a lot of these solutions leverage R5D, R5DN, or R5AD instances to get that fast local storage. But we heard from customers they want fast storage, and they want the persistence, flexibility, and manageability of EBS. With R5B and IO2 Block Express, they get both. Now, I've mentioned a few times SRD in this talk, and I wanted to talk a little bit about what that is. SRD, or Scalable Reliable Datagram, is a transport protocol that incorporates AWS's experience operating extreme workloads at cloud scale. Using our large network as an advantage. Working with the SRD team, we built a new storage fabric that takes advantage of the capabilities of SRD, including multipath and relaxed delivery ordering, to deliver high throughput, low latency, and importantly, low jitter storage from your Nitro instance to our storage fleet. This new fabric also heals more quickly in the face of failure. Now, I could spend all day talking about SRD. It's one of the things that I really love about what we've done lately. but we just don't have the time right now. So I want to leave it up that the combination of R5B and Block Express is the first to rely completely on this new fabric. Now, we plan to enable this new fabric in more regions and support more Nitro instances later throughout the year. IO2 Block Express, together with R5B instances, give you the performance of a SAN in the cloud with the power of the AWS pay-as-you-go pricing model, really without any of the headaches. Now, I'd like to invite Prarthana, also from the EBS team, to take us even deeper into the advantages of AWS SAN in the cloud.
Thank you, Mark. My name is Prarthana Karmakar, and I'm a software development manager in EBS. I would like to dive a little deeper on the SAN in the cloud concept that Mark introduced. EBS scales as your applications grow, and you only pay for what you use without any long-term commitments. So now you can start to move those applications from on-prem into AWS and start to apply the benefits of a cloud economics, even where your performance needs are the highest. When your applications or data needs change, you can easily modify the performance or storage type. The combination of R5B and IO2 Block Express is now on par with the performance of the mid-range SAN in your data centers. But you get the performance without having to buy or manage the SAN, and the complex infrastructure that comes with owning a SAN. And with AWS's constant innovation, you also no longer have to deal with the hardware refreshes just to get the new features or the performance benefits. Now, EBS prioritizes security. For us, security is the primary goal. EBS Volumes support encryption of the data at rest, in transit, and also all volume backups. EBS encryption is supported by all volume types and is integrated with AWS's key management infrastructure. And with our investment with the Nitro architecture that Mark also referred to earlier, there will be zero impact on the performance. Finally, we recently announced several new encryption enhancement features, allowing you to encrypt all new volumes created in your account with a single opt-in setting, greatly simplifying your internal security compliance programs. Now, EBS is reliable. The EBS architecture offers reliability for mission-critical applications. Each IO2 volume is designed to protect against failure by replicating within the availability zones, offering 99.999% of availability and an annual failure rate of 0.001%. That's 5 nines of durability. For simple and robust backup, use EBS snapshots with Amazon Data Lifecycle Manager policies to automate your snapshot management. Now, what are the target workloads for the AWS SAN in the cloud? Everything that you run on your in-premise mid-range SAN. These are typically the applications that are most demanding that form the foundation of your business. Things like mission-critical deployment of Oracle, SAP HANA, Microsoft SQL, really anything that requires high durability and high ops with a low latency are very good candidates. Where previously you may have had to string together multiple IO2 volumes to get the performance that you need, you can now get that performance with a single IO2 BX volume. As with any other storage type, we encourage our customers to have a robust and secure backup strategy in place to secure your data. EBS offers a fully managed backup tool which is built in with the EBS snapshots. Snapshots are a point-in-time copies of your data that are stored in Amazon S3. They can be used to instantiate multiple new volumes, expand the size of the volume, or move volumes across availability zones. When a new volume is created, you can choose to create from an existing EBS snapshot. In that scenario, the volume begins as an exact replica of your snapshot. Snapshot gives you an immediate access to the EBS volume data, the ability to resize the EBS volumes. You can also share your EBS snapshots and copy snapshots across AWS regions. Now, the snapshot functionality provides you geographic protection of your data and enables you to achieve business continuity for your organization. Mark is going to give us further details on this.
Thanks for walking us through that. So let's go through a few of the ways that you can leverage the features of snapshots to improve your operations on EBS. It's always important to keep track of your data. One of the ways that is common throughout most AWS services is the use of tags, and snapshots really are no different. You can tag a snapshot at any time, but we recommend that you tag them on creation to help you keep track of them. Oftentimes, customers use multiple tags to help with things like source and retention policies. EBS snapshots even support the ability to leverage tags for cost allocation, so that you can accurately track snapshot usage, whether it's between dev and test, business unit, or different cost centers that you might have in your organization. Additionally, you can create IAM policies based on tagging to restrict access and usage of commands like create snapshot, delete snapshot, and modify snapshot. While we're on the topic of security, we mentioned this before, but I do want to say it again. If you take a snapshot of an encrypted volume, that data will always remain encrypted. And that includes the snapshot, the data that's stored in the snapshot. But what about older snapshots that you created maybe before we had encrypted volume support or before you enabled encryption? Well, you can use the copy snapshot functionality to encrypt a snapshot when you make a copy, either into the same region or when you copy it to another region. Another powerful feature of snapshots that we've seen a lot of customers make use of is sharing. Now, it's a best practice to create separate AWS accounts that are just for your production workload. These accounts should be isolated and ring-fenced and follow a pattern of least access. Now, with snapshot sharing, you can create snapshots of your production workload and then share them, carefully, of course, with your dev and test environments, if you need to use them for, say, load testing or maybe other investigations into performance or defects. We've also seen customers build things like Omni factories, where they'll have one account that creates a production or a master Omni, and use that and share that with the rest of their AWS accounts. Now, with those best practices in mind, let's take a look at how you can manage the lifecycle of your snapshots. For small numbers of snapshots and other manual ad hoc operations, you can use the tools that you're familiar with, the CLI, API, or the Management Console. From these, you can add tags on creation, delete older snapshots, and even share them with other accounts. Now, we recommend that customers take regular snapshots to protect their critical business data. You can rely on an operator to remember to call the snapshot command, or even a computer running a cron job. With Amazon Data Lifecycle Manager, you can let us run the cron job. And you can also create sophisticated policies that include snapshot retention and creation, with tags, of course. Retention policies based on age or number of snapshots that you want to keep. So you can create something complicated like a daily with a weekly retention period, and even copying to other regions as part of your life cycle, different accounts, and maybe even your outposts. Snapshots are integrated with AWS Backup, allowing you to create more sophisticated storage plans for backup plans for multiple storage types, including EBS, EFS, FSX, and databases like DynamoDB, Aurora, and if you use application consistent backup support through SSM, your self-managed SQL Server. Now, one of the common pieces of feedback we've received over the years was the time that it takes for snapshots to hydrate into new volumes. To help address this, we built Fast Snapshot Restore, a feature that allows you to select which snapshots live in what is often referred to as a worm pool. After you enable a snapshot for FSR, volumes created from a snapshot will receive full provision performance, whether that's a GP3 volume or an IO2 volume. You can have up to 10 concurrent volumes based off of an FSR-enabled snapshot, while other volumes in that same period, other volume creations in that same period, utilize typical hydration from S3. Restoration is based on a credit system. And as volumes fully initialize, you're able to launch more volumes using the FSR, the balance of your credits, and you can view all this using CloudWatch metrics. Now, when you're done with an FSR-enabled snapshot, you can easily disable it to lower your costs. By leveraging FSR for specific recovery time objectives, or RTO, and enabling snapshots only when you need it, you can save the cost of, or enabling FSR only when you need it, you can save the cost of FSR And you can also save the cost of a warm pool of volumes and the EC2 instances required to initialize those volumes. Now, as we come to the end of our session, hopefully it's clear the features that we launch are directly targeted at the key things our customers are asking us for. We continue to lower costs for customers with volumes like GP3 and the lower price SC1. We continue to drive higher performance and reliability for our volumes with volumes like IO2 and IO2 Block Express. We continue to improve the ability of customers to scale and manage their EBS resources with features like elastic volumes and fast snapshot restore. And we continue to make it simpler to use and manage EBS securely with features like Data Lifecycle Manager and other enhanced policy-based tools. Now, obviously, you joined today to learn, and so there's a bunch of resources that you can look through.